The absolute entropy is measured relative to absolute zero, meaning a temperature of 0 Kelvin, we have a solid crystal, and that has one microstate. So according to Boltzmann's equation, we substitute one microstate in, and that gives S equals 0. So at absolute zero, you don't see rotations of molecules or oscillations of the atoms relative to each other, so the entropy is 0. And note that absolute zero has not been experimentally reached. So the entropy is taken at some constant in this state. And typically the absolute entropy is measured as the standard entropy, which is thereby always greater than 0, and calculated at 25 degrees Celsius or 298 Kelvin. And entropy typically has units of joules per Kelvin, so heat on temperature, but is presented as joules per mole Kelvin for different substances. So as we can see, a gas has a higher entropy than a liquid, which has a higher entropy than a solid. But depending on the species in a substance and the types of bonds, a solid may have a higher entropy than a liquid in some instances. And at absolute zero, the third law of thermodynamics states that the entropy of a closed system at thermodynamic equilibrium approaches a constant value, so therefore a change in entropy between two states is the difference between the entropy in the final state minus that in the initial state. And in general, we look at chemical reactions where the change in entropy of the reaction is equal to the sum of the absolute entropies of the products minus the sum of the absolute entropies of the reactants. Calculate the standard entropy change for the following reaction. So the standard entropy change of the reaction is equal to the sum of the standard entropies of the products minus the sum of the standard entropies of the reactants. So for the products, we have 2 moles of ammonia, and we multiply that by the standard entropy of ammonia given in the table. And we do the same for the reactants. So we had 1 mole of nitrogen gas multiplied by the standard entropy, and 3 moles of hydrogen gas by the standard entropy of hydrogen gas, which gives the following result. And the units are joules per Kelvin or joules per Kelvin per mole of reaction. Because for example, we have 2 moles of ammonia per mole of reaction. So that means the same thing.